In the previous video, we studied about the electron transfer concept of oxidation and reduction. And as a conclusion of the previous video, what we can say about a redox reaction? A redox reaction we can divide into two half reactions, that is oxidation half reactions and reduction half reactions, isn't it? So, a redox reaction we can divide into two half reactions, that is oxidation half reactions and reduction half reactions. That means there will be oxidation, that is losing of electrons, and there will be reduction, that is gaining of electrons taking place simultaneously. Next, in this video we are going to study about competitive electron transfer reactions, and it is actually meant for deciding or determining the reactivity or order of reactivity of different metals, to compare the reactivity of different metals. For example, if we dip a zinc rod in copper sulphate or copper nitrate solution, we know that copper nitrate or copper sulphate or any copper salt, it is blue in color, and the blue color of copper salts solution is due to the presence of Cu2 plus ions. So, for example, we are going to dip a zinc rod in blue colored copper sulphate or copper nitrate solution. So, in the first diagram, so this is the blue colored copper sulphate solution, which contains what? Cu2 plus ions. In that, a zinc rod is dipped. After some time, what we can observe? We know that zinc is more reactive than copper, isn't it? So, what happens? Zinc will displace copper from copper sulphate. So, how we can write the equation as? We are dipping zinc rod, so we can write it as Zn solid dipped in copper sulphate solution, that is aqueous. What we are getting here is ZnSO4 plus C. So, zinc. So, after some times, what we can see is, if you look at the blue color of copper sulphate solution, we can observe that there is decrease in the intensity of blue color of copper sulphate solution, and along with that we can observe a small deposition of copper. We can observe a small deposition of copper over this zinc rod, because the zinc is displacing copper from copper sulphate solution. Okay. Now, finally, after some times, finally, when the reaction completes, what we can observe is the blue colored copper sulphate solution completely it will change to colorless, and we can see a reddish brown thick deposition of copper over zinc rod. And why this blue color solution becomes colorless? Because now it has become zinc sulphate. So, here now we have zinc sulphate solution. So, initially the solution was blue in color due to the presence of Cu2 plus ions in the solution. Now, zinc displaced copper from copper sulphate, and copper sulphate solution now became zinc sulphate, and it is colorless. So, it is colorless due to the presence of Zn2 plus ions present in the solution. Now, from this experiment, what we can infer from this experiment is zinc is more reactive than copper. Only because of that, zinc is able to displace copper from copper sulfate, and there is change in the color of copper sulfate solution. So, only if there is Cu2 plus ions present in the solution, it shows blue color, and when there is presence of Zn2 plus ions, it becomes colorless. And the same equation, if we are writing the ionic equation, how we can write it as Zn solid plus in CuSO4 what we have Cu2 plus ions. In ZnSO4 we have Zn2 plus ions plus Cu solid. So, if you look at the charge of each species, zinc in the free state, it is neutral, that means 0 charge. Copper it is 2 plus, here it is Zn2 plus, and here copper in the free state, that means copper metal, there is no charge, that means 0 charge. And see what happens to the charge of zinc here. There is increase in positive charge, that means it is undergoing oxidation by losing electrons. At the same time, Cu2 plus, 2 plus becomes 0, that means there is decrease in positive charge, that means it is undergoing reduction by gaining electrons. This is what we have explained in the previous video, that is, if there is oxidation, simultaneously there will be reduction. So, whichever species is losing electron, there will be another species to accept those electrons. And this reaction mainly depends on the order of reactivity of metals that we use. There will be displacement reaction only if the metal that we are dipping in the salt solution is more reactive. Okay, so if zinc is less reactive than copper, there will not be any displacement or there will not be any reaction. Similarly, if we are dipping silver rod, this is another example to compare the competitive electron transfer. So, here zinc and Cu2 plus ions are there, but here who is actually losing electron? Zinc is actually losing electron and undergoing oxidation. The reason is zinc is more ready to lose electron because zinc is more reactive. Only if the metal that we are dipping in the salt solution is more reactive, there will be reaction. Okay. Now, if silver rod, if it is dipped in the same blue colored copper sulfate solution, we cannot see any observation. There will not be any deposition of copper or there will not be any change in the color of the solution. What does it mean? Yes, silver is less reactive than copper. So, from the first experiment we have seen that zinc is more reactive than copper, and from the second experiment we have seen that silver is less reactive than copper. So, how we can summarize or how we can club these two observations? So, if we compare the reactivity of zinc, copper and silver, how we can write the order of reactivity as the more reactive species is zinc, then comes copper, then comes silver. So, this competitive electron transfer concept is used. By this method, we can study the order of reactivity of different metals, and using this we can prepare electrochemical series. Electrochemical series is also known as activity series that you will study next year in class 12. Electrochemical series or activity series or reactivity series means the series in which the metals are arranged based on their order of reactivity. And how we are studying or how we are assessing the order of reactivity is based on this competitive electron transfer process. Now, based on this, so we know that different metals are having different order of reactivity. So, based on this concept, it is useful, or we are using to design certain cells called galvanic cells or electrochemical cells. That means the batteries that we use in torches, clocks, inverters, automobiles, etc. So, this concept is very important to design galvanic cells, which is based on activity series or reactivity series. The series you will study only next year, but the basic concept behind this activity series or reactivity series is this competitive electron transfer process. Okay.